Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I wanted to make another video for you on real life applications of statistics in Excel. And this real life application that I've got is going to be in manufacturing, where they're going to determine whether the number of defective products is acceptable or not. So you've got this manufacturing company, and they say that they want to have an error rate of 2%. So an error rate is 2 out of every 100. So if they've got 500 products, that means that 10 of those products of that 500 should be in error. If it's less than 10, that's good. And if it's more than 10, then that means there's a problem. So what we want to do is we want to set the significance level up, and I've already set up the significance level as being 0.38 because I've already tested this out before I'm making the video. I did actually make the video before and I wasn't happy with it, so I deleted it. So I'm making it a second time, so hopefully it'll be more smooth flowing this time. So we set our significance level at 0.38 because I've already tested it at that level. Our Z statistic, we've got a formula for the Z statistic, and it's B6, that's the error rate sample minus the expected error rate divided by the square root of the expected error rate times 1 minus the expected error rate divided by the number of products in the sample. So that's the formula that you come up with to get your Z statistic. And then whenever you have a 10 defective products, you're going to have a Z statistic of 0. So we check our p-value. The p-value is your probability, and it's 1 minus norm.s.dist. E4 is your Z test statistic, and true means it's cumulative. And this is just the formula that I found on the internet, and it works. So we check for a null hypothesis, and the null hypothesis we have E5, which is the p-value, is greater than E2, which is the significance level, and that makes it true. So when you have 10 defective products, it's just right on the cusp between true and false, but I made it to be true. So we're going to check for, let's say we've got 8 defective products out of 500. Again, you're going to have your p-value as 0.73, and it's going to be higher than the significance level, so it's going to be true. But let's just check. We've got 12 defective products. So the 12 defective products is going to be a p-value of 0.26, which is less than 0.38, which makes it false. So your null hypothesis is the error rate is less than or equal to the expected error rate, and the alternate hypothesis is the error rate is more than the expected error rate. And so in this particular instance, we've got a null hypothesis. We have to accept the alternate hypothesis because the defective products 12 is greater than and it has an error rate of 0.24, is greater than the expected error rate of 0.02, which means there's a problem. So that's how you use statistics in manufacturing to determine whether the number of defective products meets the criteria, whether the null hypothesis is true. So you want the null hypothesis is true because you don't want a lot of defective products. If they're defective, you have to throw them out or sell them as seconds, and you don't want to do that. So we'll just set it back here. We'll set this back here to 10 defective products. and it's true. Null hypothesis is true. So that's it for this video. It's much more concise than the last video because after I made the video, I wasn't happy with it, so I deleted it, and then I went and did some more research and did some more changes, and this is what I've come up with. So I hope you like the video. If you like the video, please like and subscribe. Thank you so much for watching my video. I look forward to making another video for you. The next video will be my last video in the statistics range for the time being.